Hi, this is William. I'm going to give a quick code walkthrough of my research scraper.py. Now it's currently running in VS Code and it's scraping pages from academic.oup.com, which is the Oxford University Press. And this is a non-headless Chrome session, which is being driven using uh, Chrome driver through Selenium. So the entry point to my module here is this scrape research function, which defines a scraping pipeline. And the pipeline defines a scrape job for every data source that I support. Like these five now. And OUP is, as I said, it's for the Oxford University Press, and I'm testing it for the first time actually now. So for the scraping pipeline, it goes through each scrape job and it runs the scraper for that job or data source, and for OUP, it's this scraper here. So let's go to that. And you see I have a search URL template defined. And then for each of the competitors, which are configured, the competitors are the pharma companies that we want to extract the research articles from. So for each pharma competitor, it builds the search URL from the template, and then it runs the actual scraping code. So you can see here I'm getting a Chrome driver, which is not headless. By default, I use a headless Chrome session if possible because the performance is much better. You can see there's some lag here, right? Because it has to render the HTML and load the JavaScript in the browser. So it's better if we don't run in non-headless mode. But for some websites like this one, the Oxford University Press, we need to run it in non-headless mode. Okay, so you see I'm using Beautiful Soup actually, and I get the page for each URL through the driver. So each of these pages are getting the HTML as a Beautiful Soup object. And here I have a while loop because I'm doing I support pagination. Even though I think for this website, let me see, where's the template, the search URL template. I think I specified a pretty big page size. Yeah, page size equals 1,000. So usually we won't need to paginate if the page size is so large. Okay, anyway, it's up to like search result 937. I think. Okay, 938. Okay, maybe it's gonna paginate it actually. All right. So as I said, I get the beautiful soup, which represents HTML, and then you see I have this custom extraction code for this particular website, getting the anchor with this class. And so this custom extraction code, I can extract um, things like the title, the article title, and article authors, etc. Now for this website, when you do a search for the pharma company, the search results page doesn't actually give you the URL for the article that you can download and extract the text from the PDF. You have to so there's going to be a search result list, and you have to go through each item in the list, and that's what I'm doing here. Like I'm getting a launch URL, so then I have to go to the launch URL, get page for the launch URL, and I have to scrape the launch URL, that page for the article soup here, to get the actual metadata that I need, like the title. So that's what the scraper is doing now. Actually, it's going through all those article pages and extracting the metadata. As I said, like title and the article URL. This is this PDF link here. You see. So it's extracted as article URL, so that later it can download the PDF and extract the text from it. Okay, and it's getting all the authors here. So once it finishes extracting the metadata from the article page, then it just stores that article's metadata into the list for all the articles associated with this pharma company. Okay, and here's the pagination here. If I find a next link, I know that I need to paginate. Okay. Okay, this go up to 960. I think it should be almost done. I think this search result. This is searching for Johnson & Johnson, the pharma company, and I think it only has 961 search results. So yeah, so I set a breakpoint here. Actually, I'm going to test this for the first time to see if this pagination code works or not. I set a breakpoint here because I want to test. Now I think yeah, this is this should be the end of the search for Johnson & Johnson. So let me just step through here. So I should not find a next. Okay, it's looking for next. Yeah, so got an exception here, right? So you can see, okay, let's step. Okay, the exception. Yeah, no such element, right? So I was looking for the next link, and I didn't find it. So I know that there are no more pages, and I can break out this while loop. I don't have to paginate. Okay, so I found. Let's see. Yeah, so I found. Okay, it's not refreshing here because I think there's too much memory being used to load the 961 metadata list. Okay, anyway, now let's check here. See the article URLs? So these are all the URLs which I extracted. Okay, actually 957. Okay, the reason why it's 957 because I actually check if there's a PDF link. Some articles don't have a PDF link, like they're not actual research articles or not the type that I can use. So I don't include those in the list. Article titles, it's a parallel list. So these are all the titles for those articles and the article authors. Wow. Everyone wants credit. These are low, except this guy. This guy is the sole author. Okay, so then I quit the driver. You see it quit there. Now, okay, let's go on. Let's see. Okay, so um, actually, then I'm just testing this. So for Johnson Johnson, so that's one run through the scraping for the metadata.